Hey everyone, today we are looking at an open square-based box that we are told has a capacity, meaning an ability to hold liquid, of 120 milliliters. So that's going to speak to its volume. And I'll remind you that 1 milliliter is equal in volume to a cubic centimeter. Okay? So when we're told that a box has a capacity of 120 milliliters, what we're really being told is that its volume is 120 cubic centimeters, okay? Next, we're told that it's made from a square piece of cardboard. So let's draw that out so that we can build some kind of visual model for what's going on. It is a square piece of cardboard, so we know that its length and its width are identical. We don't know what they are exactly. Let's call them some unknown. Let it be X. And it's made from this square piece of cardboard with 4 centimeter squares cut from each of its corners. And so that means that in each of the corners, like so, we get a little 4 centimeter square being cut out, okay? And then obviously all 4 corners are identical. And so here is our now square piece of cardboard along the ground with 4 corners cut out. It needs to end up in the shape of a box. And so if you can imagine these corners actually being cut out and no longer being a part of the cardboard, what we're left with, these strips on all 4 sides, can now be folded up. They can all be folded up to actually make a rectangular prism, a box, okay, where you could actually pour liquid in or pour anything in. And so its length and its width now are no longer X because 4 centimeter have been cut out from each of its corners. And so its new width, let's say, it's, how should I? Let's use a different color. Let's use a different color. This new width, let's say, is gonna be X minus 4 minus 4, right? Minus 4 on both sides, and so altogether, we'll have a new width of X minus 8, okay? And then obviously the same thing for its length. And so its new length will be, again, X minus 4, and so identically X minus 8. So when we think of our box that will be made from folding up, again, these 4 strips, folding up the sides to make the vertical component of the box, that vertical component is going to be exactly 4 centimeters in height, right? This piece the box, that's what's being folded up. And so 4 centimeters are being folded up into a vertical component for the box. And so that means that for our box, we have a width of X minus 8, a length that is also described by the expression X minus 8, and we have a height with a numerical known value of 4, okay? Or rather 4 centimeters to be proper along with units. So now we have an expression for the dimensions of the box, and we know what its volume actually is. And so that's going to allow us to make an equation, and that will let us solve for this unknown X. So let's go ahead and do that. The volume of a box, very generally speaking, volume of a box is length times width times height. We know our volume. Numerically, it is 120, and that's equal to the length, which we said was defined by X minus 8 times the width, also defined by X minus 8 times the height of 4. This is a very nice quadratic equation that we know how to solve. So let's go ahead and do that. First thing we can do before we expand this bracket out, let's divide both sides by 4 to make our life a bit easier. So we divide by 4 to cancel out this factor of 4. Same thing on both both sides. And so 30 is now equal to x minus 8 times x minus 8. Now, we could expand through this bracket, and you might have that pattern ingrained in your mind, but I'm gonna note that this, written in another form, is 30 is equal to x minus 8 all squared, okay? This will be a bit more convenient to solve algebraically, because since 30 is equal to x minus 8 as a binomial all squared, right away, we can take the square root of both sides. And this is kind of like completing the square without actually having to go through completing the square from the equation in standard form. It was kind of already there for us. And so let's make good use of it. So now we have x minus 8 being equal to, when we take the square root during the solving of an equation, we have to consider the positive or the negative version of that square root. And now to isolate our unknown value x, we'll add 8 to both sides, meaning that x ends up being 8 plus or minus the square root of 30. Now, if you've done problems like these before, you oftentimes have to reject one of the two possible solutions. And that's exactly what we're gonna do here, because I'm gonna argue that if x is equal to 8 minus the square root of 30, let's say if x is 8 minus the square root of 30, the square root of 30 is between the square root of 25 and the square root of 36, and so the square root of 30 is very roughly around 5.5, right? And so that would mean that x would be roughly 8 minus 5.5. And that would mean that x would be roughly 2.5. And if x is roughly 2.5, then its width along with its length would be around x minus 8, meaning around 2.5 minus 8, which would be around negative 5.5. And if we live here on Earth, we can't possibly have physical dimensions of an object with a negative length, right? With a negative numerical value, right? And so this is clearly not plausible. And so for that reason, I will reject the negative square root of 30 as a viable solution. And so we get one unique solution for x, namely that x is 8 plus the square root of 30. We could write that as a decimal. It would be roughly, 8 plus 5.5, so roughly 13.5. I'll put that in brackets. Roughly 13.5. But to keep it as an exact value, I'm going to leave it as 8 plus root 30. Now, we're not done, because the question did ask us to find its dimensions of the box. And so we had its dimensions laid out as functions, I guess, of that unknown variable x. Now we know what x is, and so we can actually find the numerical values of our dimensions for the box. So for the box, its width is x minus 8, meaning 8 plus root 30. 8 plus root 30 minus 8, right? X minus 8. And you'll see that very conveniently the 8 cancels out, right? 8 plus root 30 minus 8 cancels out. And so that means that we get a width of simply root 30. The length is the same as the width. So again, 8 plus root 30 minus 8 means that our length is identical to the width, namely root 30 as well. And we already knew that our height was 4. We should include our units here. We know our units for the dimensions are centimeters because our volume is in centimeters cubed. And so here are our 3 dimensions for the box. We can easily check that to make sure we haven't made any silly errors along the way. We know the volume should be 120, and the volume is very generally speaking length times width times height. And so we can check. How did I spell that word? We can check if 120 is equal to, again, length times width times height, meaning is 120 equal to root 30 times root 30 times 4, question mark. Let's verify that it is. We have square root of 30 times square root of 30, right? The square root of anything times itself is the thing we're taking the square root of, right? And so root 30 times root 30, obviously, is 30. So that's 30 times 4. And is 120 equal to 30 times 4? Absolutely it is. And so we verified that our dimensions are in fact correct. And so our box is, as a result of cutting all 4 corners and folding out the sides, we get a width and a length of square root of 30, again, roughly, that's roughly 5.5 centimeters. And we get a height of 4 centimeters. I really like this problem. I thought at first glance that our dimensions were going to be nice integer values, but root 30 is a nice exact value at the very least. And so I hope this helps. Thanks for watching. If you guys have any other problems along the lines of this topic, please let me know in the comments. Thanks for watching.